Hey, good morning, everybody. Great to see a full house here. My name is Mike Diamond. I'm the Principal Product Lead for Responsible AI for AWS. And I'll be joined today by Louis Baker, who's the Senior Data Science Manager and Head of AI for Indeed. And we're going to be talking about scaling AI responsibly. Okay. Every AI system incorporates a specific posture towards responsible AI, by which I mean it is built upon a set of decisions and positions in regard to how it should operate responsibly and minimize risks. And I think what I'm saying will become clearer if I walk through a couple of use case examples. Let's take for the first example, a real estate company. Let's say they are building a system to output property descriptions of condominiums for buyers and sellers. They have to consider, does the generated text welcome all buyers, demographic groups equally? Are the property features accurately captured, or are there hallucinations in the descriptions of the properties? Have any private details leaked in to the descriptions from previous owners and occupants? And is the content that they're using, the images that they present, does it contain unsafe or illegal content? Let's quickly think through another example here. Here's one that many folks I know are working on today. A shopping agent for an e-commerce site. As this e-commerce company is building the site, they have to consider, can the agent provide specific recommendations to individuals that are meaningful for that individual, but also equitable across the different demographic users of that site? Is it susceptible to accumulating unauthorized charges or exceeding budget? Does it appropriately share any PII information across the payment rails? And is it vulnerable to manipulation attacks designed to do things like trigger unauthorized refunds at scale? Each of these questions across these two use cases represent inherent technical properties of AI systems, whether the builders of those AI systems address them intentionally or not. And of course, there are consequences of not addressing them intentionally. The OECD, which is the Organization of Economic and Cooperative Development, has an AI monitor that they use to track incidents and hazards over a number of years. Incident is defined as a harmful event, an AI event that has harmful impact upon individuals, and a hazard is one in which potentially could have caused harm to individuals, but may have caused reputational damage. And as you can see in the chart that I'm sharing here behind me, is that in October of 2025, it hit the highest point with 509, which is a 95% increase over the same time from last year. And of course, this rise during this time period corresponds to the expanded use of AI that we've seen over the past couple of years with generative AI. So at AWS, we define responsible AI across these 8 categories that you see here. And when I say that when I said that there are technical properties that are inherent to an AI system, these are the types of properties I'm talking about. And traditionally, folks who are trained in machine learning are trained in order to optimize the predictions towards accuracy against a loss function. Responsible AI is the art of maximizing the benefits of an AI system and minimizing the risks across these 8 dimensions, including the trade-offs that are required between them. Very quickly, these dimensions, these properties that we track here at AWS, controllability is the property around having mechanisms to monitor and steer the behavior of the AI system. Privacy and security is around appropriately obtaining and using the underlying data and models that power that system. Safety is the property around preventing harmful misuse around things like scams. Fairness considers the impact of the outputs of the system upon different stakeholders and groups. Veracity and robustness are the properties around achieving correct outputs, even with unexpected or adversarial inputs. Explainability is around understanding and evaluating the outputs. Transparency is similar to explainability, but it's around guiding the stakeholders and enabling them to make informed choices about the use of that AI system. And governance incorporates best practices for these technical properties of AI systems across, and I'll be talking more about that as I go. So in my role as a principal product lead for Responsible AI, I get to meet with many of you folks and customers, and they share with me sometimes some of the challenges around addressing responsible AI at scale in their organization. So one of them is that each of these technical properties requires a certain amount of expertise. There is a science to each of these properties to addressing fairness. There's multiple ways that you could measure fairness, for example. For looking at robustness, there are multiple ways you could do that as well. So there's an expertise that's required. The second kind of a challenge that I hear as I talk to customers is that there are many tools that are provided in the open source community by AWS, by third-party vendors, but kind of piecing these tooling together into a holistic solution that you could give to your builder teams across the AI lifecycle is more challenging. In some organizations, investing in responsible AI is seen as a bottleneck to innovation. We're going to talk more about that. And then I'm on the responsible AI team here at AWS. I've seen this personally, but many of the responsible AI experts within organizations feel overwhelmed as the number of AI use cases they need to support has increased so much over the last couple of years, with those teams staying constant. One healthcare company I work with, I remember, told me that they have a backlog for the responsible AI expert team of over 1,000 use cases to review. And then, of course, responsible AI involves compliance, depending on the jurisdiction that you're operating in within Europe, within Colorado, within California, as well as management standards like NIST and ISO 42001. And builder teams have to deal with outputting evidence in the right format to comply with those regulations. So how do we address these challenges? Okay, so the first thing I want to say, and maybe this is going to be controversial, maybe not, but that across all of the RAI technical properties or dimensions that we just discussed, when you look into mitigating risks, there are three overarching strategies you could use to address any of the risks. And I'm calling them here baking, filtering, and guiding. So what are they? So baking involves building into the AI system itself the desired behavior that you want. If you're looking to mitigate risks of unwanted bias, you may do this by building out data sets with distributions of demographic groupings according to how the system will be used. Or if you're looking to mitigate risks of hallucinations, going back to that use case we were discussing, you may have a RAG pipeline that would ground the answers in data. Filtering is around blocking both inputs into the AI system as well as outputs that come out of it. Again, going back to our use case with the condominium description, we may want to put in guardrails that would filter or block out the PII, or personally identifiable information, from entering into the AI system, or the output as that system integrates with APIs or return to the user, you may be filtering out. So that's filtering. And then guiding is around steering your users, the users of the system, which could be human users, or they could be agents or other systems, around the proper use of that system, the intended use, being transparent about the limitations of the system through things like data cards, model cards, AI system cards. So those are the three overarching techniques that we use to address responsible AI. Maybe by a show of hands here, how many folks are familiar with the three lines of defense model that's used in regulated industries to address risks? Okay, I see a good number. That's good. What I've done here in this slide is applied that model, which I'll describe, to AI risk management. So if you start all the way over on the left, that's your first line. Those are your builder teams, and they're responsible for building the actual safeguards and controls into the AI system itself. Your second line is that group that I talked about, the group of AI experts that support the first line. There'll be multiple second line teams at organizations. You may have a cloud security second line team. You may have compliant, more money laundering or other forms of risk management that you're working with, that a second line team will work closely and guide that first line team and help them and set up practices. And then all the way on the right, you have the third line. That's ultimately your internal audit and your independent assurance roles. And these teams interface with the external auditors on the right that you see there, as well as with different agencies and consulting agencies, and they provide the internal security, the overall assurance to the organization. Now, when organizations talk about sort of responsible AI being a bottleneck, often what I see is that responsible AI is being addressed in that handover between the first and second line to the third line. And if you're addressing your responsible AI there, it's too late, because now you have to re-architect and you have to start over again. And just as in security, we solve this by the notion of secure by design, as a concept many folks are familiar with. We use a concept called responsible by design. And it's taking the policies ultimately that are set by the third line that relate to the various management standards and the regulations, translate them into a set of best practices by that second line, and push those best practices now to your builder team. And that eliminates a lot of the bottlenecks and can accelerate your development practices. So that's what we've done here at AWS. We have defined what we call our responsible AI best practice framework, which is represented here on the slide. And this is the framework that's used by our builder teams as they build the AI services that you'll hear about over the next couple of days, or that you're using currently. And there's a couple of benefits of doing it this way. The first benefit we just discussed, which is the more you could shift left your policies into your builder team so that they're building correctly the first time, the more you could accelerate your innovation. The second, and I should have made a slide on this, I think it really would have helped. But if you think about on the right, you have your management standards, you have your policies that your organization is setting, you have your regulations that, like we discussed, and then all the way on the left, you have all your tools. And there are new tools that come out every week in the open source community by vendors that address different properties of responsible AI. So those are two very dynamic layers. And if you put within that, in the middle of it, a best practice framework, like I'm positioning here, it gives stability and robustness. You can map and onboard new toolings, map it onto that best practice framework, and the outputs can be in a standardized format that can meet multiple regulations on the right side. So what are the best practice framework? And I'm going to go through it at a very high level. You can see it here that it's on the slide. You see that it spans across the AI and ML lifecycle: design, develop, and operate. The first set of best practices that we've defined for our builders teams is around narrowly defining the use case, the intended use case. And this is a very common problem that I've seen with builder teams, which is if you define it very widely, very broadly, you're increasing your risk exposure significantly. Narrow the use case properly, and you narrow the risks right up front. Then for that use case, we've defined a set of best practices to help them identify the inherent risks of that use case. So consider the actual stakeholders individually, and then go through a framework like the slide I had with the 8 dimensions on it, and consider how for each of the stakeholders, what are the potential risks, and then rank those risks according to their impact, according to the likelihood or frequency with which they'll happen, and then so that you could address them. So setting up best practices around identifying risks for builder teams. And then the third is really a working backwards mentality. So initially upfront, even during the design phase, establish release criteria, metric-based criteria for how you're going to measure the highest risks that you're concerned about from the previous exercise, and then define the metrics and the thresholds for those metrics as release criteria. Now this is represented intentionally as a circle because this will be iterative, and of course as you learn more about your AI use case, you may want to adjust those as you start to work with the data, but it's important to set those goals up front as design principles and then work backwards from the metrics. So the next set of best practices that we've defined are during the develop phase. So for each of the release criteria that the teams establish, and for each of the risks, you need a way to test it. And so even before we design the system, we designed the testing sets that will test the individual risks. So to make sure you have, based on your understanding of the inputs and outputs, if you're testing for fairness, do you have the right demographic groupings within your data that are in a statistically valid way? So develop data sets, and you could use one data set across multiple risks, but make sure you have data sets for testing all the risks. And then design and build the AI system, and this is where the previous slide, which we talked about, baking, filtering, and guiding, or steering the users, where that comes into play. Using those three overarching strategies, design the system to address those risks, and then actually test it, which is run your evaluation with your evaluation suites. And then you'll have, at the end of that, you may have risks that are still present, in which case, that's why, again, this is a circle and iterative. Or you could accept those risks, but document them. And that's really, they're on the next set of best practices, which is our teams will build out guidance tools, which really are, again, data cards, model cards, AI system cards, which we provide to users of AWS, which guide them and are as transparent as possible around the limitations of the AI system itself. And then when you get into the monitoring phase, then again, define a set of metrics that relate to your specific release criteria and make sure you're in an ongoing manner now monitoring the same set of metrics. Okay. I don't know if folks saw this, but last week we actually published a version of the responsible AI framework that I just discussed that we use internally. And if this is inside of the well-architected tool. So previously within the well-architected tool, there was a machine learning lens and there was a generative AI lens. And now there's a responsible AI lens that's based on the AWS responsible AI best practice framework that I just discussed. And the focus areas here in this pie are the same focus areas for the lens that you see there on the left and that you use. For each of the focus areas, you can see there are between 1 and 5 questions that you answer. And then for each of the, and this is showing one of those questions, how to define the specific problem you're trying to solve. And then for each of the questions, there's 1 to 5 set of best practices for fulfilling that. And then on the right side, there is a paragraph which tells you about that best practice with a link which opens up a guidance paper, which is, I think, very valuable, which will give you more information about the implementation steps for implementing that best practice. I should say also that this framework is also available on GitHub. We published it there too. And then the well-architected tool, once you complete it and you answer all the questions, at the end of it, you get an assessment. So you'll get a list of high, medium, and low risks to consider, and you'll get an improvement plan, which is shown there on the bottom, which will be specific to how you've answered the questions. So I encourage folks to see that. That's our first publication of the AWS Responsible AI Framework, and we'll be updating that over time. Okay, so the last point I want to make before handing it over to Lewis is that once you've defined your best practices in a framework, it's not just your human builders that benefit from this process, but agents, and as we all are investing more in agent-driven development and specification-driven development, agents can read natural language and can read your best practices just as your builders can. Gartner talks about guardian agents and using them for trust and safety. This is that concept, defining your responsible AI practices as a set of best practices for your agent. So let me show you a little bit about what I mean by that. So this is Kiro. Are folks familiar with Kiro? Good nodding heads on this one. Good. So Kiro, for anybody who hasn't tried it or unfamiliar with it, it's an integrated development environment, and it has within it an agent. And one of the novelties of Kiro is that it incorporates the idea of specification-driven development. And I should say it does not come with the AWS Responsible AI Framework in Kiro. I've added it here. It's not hard to do. I just did it, and I'll explain how I use the Kiro constructs to do that. So Kiro distinguishes between 2 types of specification files. One is steering files, and those are more of your organizational policies and best practices. So the Responsible AI Best Practice Framework fits very neatly into that concept there, and that's teaching the agent about how to guide the builders. And then they'll create, once a builder starts a project, they describe the project to Kiro in natural language, and then Kiro will output use case specification files, which are at the top. So this is the same condominium description use case we discussed earlier. Kiro has read the best practice framework and starts creating specification files to address the different parts of it, which your builders now should review before Kiro starts creating code, but then ultimately they'll be creating code according to the best practices. Okay, Louis.
Thanks. Hi, everybody. My name is Louis Baker. I am a data scientist and a manager and the head of responsible AI at Indeed. So Mike and I have been talking for quite some time, just as mutual information sharing, product usage, about responsible AI. And he asked me to come up here and tell you a little bit about a practical application of responsible AI at Indeed. So, for those of you who are unfamiliar with Indeed, you might know us as the job website. What you might not know immediately is the sheer scale that Indeed operates. Indeed has 635 million job seeker profiles. That is resume data from individuals looking for jobs. And we have 3.3 million employers who are trying to sort through all of those people looking for jobs. A lot of the time, when I talk to people within the industry, but more often at social gatherings, and I tell them that I do responsible AI at Indeed, they're like, oh, I didn't realize that Indeed used AI. And the reality is that AI is the only way that you can sift through that. Indeed is not a job board. Indeed is a search engine. So it starts all the way at the top, with the jobs, having all the jobs in one place. You need more data about those jobs. You need to understand what it is that people actively need in order to do that work. You need to advertise those jobs to get more traffic to the website. Once you have more job seekers, you need to understand what exactly they're looking for, what skills they have, what skills they don't have, what skills they list. Does anybody put Microsoft Word on their resume anymore? That's a question you need to figure out. And as you identify the jobs that people are applying to, the skills required, you're able to identify what leads to success that gets you more employers, and the cycle continues. I go through all of this to tell you that, Indeed is an AI company, and AI is deeply embedded in every single thing that we do. So let me give you a specific example that we can talk through about how to do this responsibly. So this is the Indeed Career Scout. And Career Scout is a fairly straightforward chatbot experience. You come in, you have a list of recommended options that you can go through, or you can just have an open-ended conversation about your career. Some of the highlighted tools are to build up your resume, to just do a job search, or to search for jobs outside your current field. And if you go down that first, you can have an open-ended conversation about, I've been working as a receptionist for quite some time. I've been interested in a creative field. I'd like to try that out. And Career Scout will guide you through what skills you have, what skills you need, what sort of options might be available for you to make a lateral career move. And afterwards, it'll give you a series of jobs that, you can say, yeah, is this what you're looking for? And eventually, you can apply to those jobs. So it's conceptually, it's very simple. You're just having a conversation. You're just trying to find a job. And with any luck, we'll help you get one. So there's challenges with this. Every simple system has a million ways to be used incorrectly, simply. If you're at this talk, you probably have heard of things going wrong before, so I'll speed up through it. But for example, less than 2 years ago, a Google AI overview, if you asked it how many rocks a person should eat, it recommended about 1 to get your daily nutritional value. That's not great. It's not super harmful, but you get the point. Later than that, if you asked it about smoking while pregnant, it would say, 2 to 3 cigarettes a day is great. That's target. It's not, for the record, but again, not good. Now, I've purposefully given you some fairly mundane ones. You might be thinking like, oh, what's the big deal? And let me tell you, I've seen some truly terrible things, awful things and that I won't share with you here. But if the safety of other people or concerns of people who should be informed not to follow the advice to eat rocks don't concern you, then perhaps it might concern your bottom line when in this very real circumstance, an early, to be fair, very early version of ChatGPT, when embedded as a chatbot into a car sales dealership, not only sold someone a Chevy Tahoe for $1, it said that was a legally binding statement. And I guarantee you that harm for the company is real and is a thing that can come out of agents. So the question here is, how do you keep AI on the rails? And Mike walked you through like a high-level framework and some specific tools within Kiro to do spec-driven development. And I'd like to go into specifically how Indeed has done this. Going back to the AI dimensions that Mike talked about, there's a whole landscape of things to worry about out there. For Indeed specifically, we have a very robust security team, privacy teams, governance teams. So for responsible AI, I'm going to concentrate on these 4 things. Not to say I don't care about the other things, but we have to get out of this room eventually. So we're going to focus on safety, fairness, transparency, and veracity. So how do we make sure that things are truthful, fair, they make sense, and they are safe for use? Our general strategy is to follow this flywheel, to anticipate what could possibly go wrong beforehand, and use this to inform things at the design stage. So this is what Mike was talking about when it comes to spec-driven development. You need to center having something safe as a design requirement, and you need to have tangible metrics in order to get there. Once something's out in the world, you cannot just trust that things are going to go the way your developers thought they would, and you need to put in guardrails in place. And I'll talk through a little bit about what some real-time guardrails are here, but generally, any sort of moderation system can be viewed as a guardrail. And then lastly, you need to observe. I am probably speaking to the choir, but if you don't log it, it didn't exist. You need to know exactly what happened. You need to be able to learn from that experience so that you can anticipate future problems. And just in general, make your product better. This entire thing, as an umbrella term, is known as AI alignment. And the idea of AI alignment is that you want your open-ended AI system to be aligned with your values. Kind of makes sense up front. When you dig into that concept a little bit more, the question then becomes, what are my values? So I know, right, that like my job at Indeed is to help people get jobs. Great. I want whatever I do to help with that. And I know in general, I don't want people to have a bad experience. But then there's all the stuff in the middle, right? Like I obviously don't want my chatbot to be making threats of violence. I don't want it to be using hate speech. What kind of tone do I want my chatbot to have? Do I need it to be very, very rigid and stuffy? Do I want it to make jokes? Do I want it to stay specifically on track with helping people to find a job through the job search? Do I want it to be able to do other things? Like if somebody asks me to do their math homework, am I going to let the chatbot do that? These are all things that need to be settled way, way, way before you hand this problem to your responsible AI team. This is a problem of human alignment. And the way that we handled this at Indeed is we got all my lovely peers from a whole bunch of different departments in a room for like 3 hours, and we hashed out exactly what it was from each of our perspectives that a good product looked like. So I can speak, of course, for responsible AI, but trust and safety, security, they have a very specific posture that they want their agent to also uphold. We put all these things down into an AI constitution, and it is exactly like it sounds. It is a big old document where people just said, thou shalt and thou shalt not. We want to help people get jobs. We do not want to pose any sort of privacy event. We don't want to have any sort of security threats. We do want the experience to be relatively seamless. We do want to keep people on the website to do their searches, et cetera, et cetera. And from this is where you get your spec. This is where every time a new product is developed, people will reference the AI constitution and they are able to align it by design. They are able to say confidently what sort of tone their chatbot should have, what sort of data it should have access to, what sort of data should be deleted after a session is over. We then further go into this by saying, great, now that you've built it to this, let's build guardrails that check to make sure that it works. Guardrails are as simple as having a parallel prompt, or maybe even something in the system prompt that just says, make sure that whatever is said follows X, Y, and Z standards. And then, at the very end, you observe. You make sure that X, Y, and Z standards are followed. You make sure that you label anything that got flagged by your guardrails so you can monitor it. So you can see, great, we flagged this as a harm. Let's look into it. Let's see what kind of harm. You look into it, you see what kinds of events have happened, you look into it, and you identify things that you missed. This is how you go from big human alignment to AI alignment. I guarantee you it's harder than one slide would state. So let's look specifically at how we did alignment for Career Scout. So again, Career Scout, open-ended conversation, what you want your career to be. Well, to anticipate the issues that might happen, we sat down and we created a series of AI red teaming events with specific rubrics that would calibrate what was and was not acceptable. And so before anything got out the door, we created an adversarial AI agent, an attacker LLM, and we loaded it with a prompt. That prompt could be try to discriminate, perhaps try to get somebody's social security number, perhaps try to engage someone with a scam. The adversarial LLM then goes, it talks to our chatbot over and over again, and every single iteration we have a series of rubrics to try to identify, all right, did a scam successfully get past our guardrails or not? We rinse and repeat this. We do this several thousand times with several different agent personas to see how robust our guardrails actually are. And now, when things go into production, we have anticipated a great range of potential harms that we can guardrail against. The most basic of this is standard content moderation. Even that's very complicated, but in general, one of our values is we don't want our chatbots to swear at people, so we have filters to make sure that there's no swearing on our platform. Things get more complicated, things get more contextual. So we also have contextual guardrails. These are secondary system prompts that evaluate whether something is going along our terms and conditions. These are the sort of things that allow you to detect whether something is a harm or not. So if you ask the agent to tell somebody to kick rocks, that's not a very nice thing to say. You can use your imagination to escalate the sort of language, please. We have a guardrail prompt that says, do not allow the following types of speech. Also give it this flag. This one is flagged as a harm. It says, do not facilitate hateful or harmful topics of conversation. An LLM as a judge has rated this above our threshold limit and has flagged this as harm. And so instead of generating a response, the AI now generates the response, I'm sorry, I can't tell people to kick rocks. So that is functionally what a guardrail looks like. Then, after you have your product, You have tried to anticipate how it could go wrong. You've built guardrails to keep it from going wrong. You then observe to see what actually happened. A major part of this is just logging events. You don't necessarily have to log them forever, but you do need to log them to know what happens. Anomaly detection is a big thing. Is there any event that's causing your moderation system to get tripped more regularly than not? It could be an adversarial attack. It could be that something's trending on TikTok. It could be that something's broken in your system. Either way, you need to be able to detect it. And then there's something that we lovingly refer to as our unknown analysis, which is that you take a very large sample of events that were not flagged, and you press it through a bunch of experimental things to see if there's anything you might have missed. You perform cluster analysis to see if there's any conversations that are on the edge. You know, it could be that 99.nth floating degrees are people trying to search for a job, and there's always, you know, a fraction of people out there trying to figure out how to build a car from scratch. And you want to figure out what's going on there and how it got past your guardrails. I say all of this because I really want to drive home a point that Mike made up front. Every single AI system has a responsible AI posture. If you are driving responsible AI from a policy perspective, you are too late. Responsible AI begins before a single line of code is written, before a single wireframe is drawn up. Responsible AI is an infrastructure investment. Responsible AI at Indeed is part of our AI infrastructure organization. We are a necessary part of R&D. To have that, to give you some demonstrated things, we currently have 17 active guardrails. We have them propped up across every single AI interface at this company. And we are currently processing 10.6 million AI responses a month. If we were a policy team, we would not be able to do all that by hand. We can't just go to every single team, ask them, pretty please follow the rules. I wrote it down, thank you. What we've done is we have created a series of tools, we have created a series of checks, and people cannot release their model into production until they have passed those checks. The takeaways that I want to give to you all right now is that, first and foremost, principal part of responsible AI is knowing what your values are, getting alignment behind them. You need to know what your company does and does not want. You need to know what is and is not possible. And you need to tell your developers that, because they're going to assume if you don't. You need to embed responsibility at every single stage of development. Every single system has an RAI posture, whether you like it or not. There's a whole mess of ways that something can be used. There's a whole mess of regulations that you might not even know about. You need to anticipate those. You need to build up guardrails for them. And then you need to monitor what actually happens. At the very end, find a path towards platformization. Mike gave you several wonderful options earlier. You can build this stuff into your development. You can build checks in. You can do things responsibly so your developers don't have to. So that's everything. I'll have Mike come back up to close us off.
Okay, great, thank you. So just some links if you want to scan the QR codes there. If you want to learn more about responsible AI at AWS or at Indeed, those are the first top two boxes. That'll take you to the websites. The responsible AI lens that I showed, which is available in the well-architected tool, that's the QR code that'll get you there. And then, of course, Kiro, if you're interested in using that, that's the link there. And then a few more. If you're interested in learning more about AI at AWS, here are some courses that, to consider on your learning journey.